Welcome to DIY Project Designs, where we design your future DIY projects using FreeCAD as our design tool. If you're passionate about building your own projects or learning how to design things from scratch, you're in the right place. Whether you're a beginner or an experienced maker, you'll find easy-to-follow steps to design your own creations, along with key design tips to ensure your project is not just functional but also well-built. Don't forget to like and subscribe. There will be many more design projects in the future. In this video, we will design a single-door base kitchen cabinet using wood boards. Kitchen cabinets can be built using different types of boards, but the choice can impact both the aesthetic and structural quality, as well as the overall cost. Beyond price, material availability is another factor to consider, as certain materials might be hard to find locally. Some lumber stores only sell full boards, which can be costly and challenging to transport. Boards and wood products come in various quality levels. Even if they look similar, one plywood board may be superior to another if it was made from carefully selected, defect-free wood, used higher quality adhesives, or received more attention during production. This applies to all board types. Still, I've seen inexpensive particle board, the kind often overlooked, used effectively in interior design projects with impressive results. The most popular boards used for kitchen cabinets are either plywood boards or particle boards with a melamine finish on both sides. Let's start. Open FreeCAD, File, New, and start a new project. Save it as frameless single base cabinet. The file is now ready for design inputs. Open the spreadsheet workbench and create a new spreadsheet which we will use to enter the dimensions of the cabinet we will design. Rename the spreadsheet to Dimensions and open the spreadsheet to enter the parameters. First, we create the list of parameters we would like to use for our cabinet, starting with the cabinet height. Now the cabinet width and the cabinet depth. The toe kick height and the toe kick depth. We must also allow for the small edge of cabinet around the door. Now for the width of the strips to mount the cabinets against the wall and fix the countertops with. The thickness of the boards will also have an impact on the dimensions. In this design, we will only mount a backboard to the cabinet. List the backboard thickness parameter. That concludes our list of parameters needed for the base cabinet. Increase the width of the first column to view all the parameters. Next, we'll add the cabinet dimensions to the parameter list, starting with the cabinet height. The standard height for kitchen base cabinets is 900 mm, but we need to account for the countertop thickness. With a 30 mm countertop, set the cabinet height to 870 mm. Standard concealed cabinet door hinges support door widths up to 600 mm. Set the cabinet width to match this maximum door width. Set the base cabinet width based on the countertop width you plan to use. For a 600 mm countertop with a 30 mm overhang, the cabinet width should be 570 mm. Standard toe kick heights are typically 100 mm, with depths of around 80 mm. A border or gap of 2 mm around the door will be adequate. A 100 mm wide strip will provide sufficient space for mounting. For this design, we select a board with a thickness of 16 mm and a backboard thickness of 3 mm. Next, we need to set up the aliases. An alias serves as a link or reference between the design and the parameters, allowing us to input the design dimensions. Use aliases that you will remember during the design process, and keep in mind that aliases are case sensitive. The next step is to design the cabinet bodies using the Part Design workbench. Start by creating a new body and renaming it to Side Panel for the first cabinet component. Create a new sketch and select the XZ plane as the workspace for this sketch. In the Sketch workspace, choose the Polyline tool to draw the outline of the side panel. Next, we'll begin adding constraints to the sketch. First, ensure that all vertical and horizontal lines are properly aligned. To set the first dimension, click on the back line of the panel, select the Dimension tool to specify the cabinet height, and press Enter. In the pop-up window, click the small expression symbol in the entry field. Here, we'll link to the parameters defined in the Dimensions spreadsheet. Begin by referencing the Dimensions spreadsheet. Type Dimensions and select the Dimensions reference within the double brackets. Type the alias reference for the cabinet height and select the correct alias from the list. The cabinet height is indicated in the length cell. Press OK. Now for the cabinet depth, select the top line for the cabinet depth and Dimension tool. In the Expression pop-up window, choose the Dimension spreadsheet and reference the cabinet depth alias. The specified cabinet depth will then be automatically applied. Press OK. Select the toe kick height line and enter the toe kick height alias in the expression cell. Zoom out, navigate to the toe kick depth line, and select it. In the expression cell, enter the toe kick depth alias and click OK. To fully constrain the sketch, apply a symmetrical constraint on the top line relative to the z-axis. First, select the endpoints of a line, then select the z-axis, green line, and click the Symmetric Constraint tool. The sketch should now be fully constrained. Close the sketch workspace and zoom out. With the sketch selected, click on the pad icon to extrude the sketch and add volume. Next, click the small expression icon in the length entry field. Choose the Dimension spreadsheet and enter the board thickness alias. Select OK. The side panel is now fully extruded. The next body of the cabinet will be the shelf. Create a new body and rename it to Shelf. In the shelf body, create a new sketch and select the XY plane. Select the Rectangular Drawing tool and draw a rectangle on the x-axis. Apply a symmetrical constraint on the bottom line of the rectangle, relative to the y-axis. First, select the endpoints of a line, then select the drawing center point, and click the Symmetric Constraint tool. Select the shelf width line, then choose the Dimension tool and press Enter. Click the small expression icon in the length cell, and then select the Dimension spreadsheet. Keep in mind that the two side panels will decrease the cabinet's internal width by the thickness of both boards. The shelf width will be calculated by subtracting twice the board thickness from the cabinet width. Be sure to include a space between each component of the formula. Enter. Select the shelf depth line, then choose the Dimension tool and press Enter. Click the small expression icon in the length cell, and then select the Dimension spreadsheet, and enter the cabinet depth. Press OK. The sketch is now fully constrained. Close the sketch. With the sketch selected, click on the pad icon to extrude the sketch and add volume. Next, click the small expression icon in the length entry field. Choose the Dimension spreadsheet and enter the board thickness alias. Press OK. We would like to create the strips on the same plane as the shelf. Select the shelf body and press the spacebar to hide it. Now create a new body for the strip and rename the body to Strip. With the strip body selected, create a new sketch by clicking on the sketch icon, and select the XY plane. In the sketch workspace, select the Rectangle Draw tool and draw a rectangle coincident on the x-axis. Apply a symmetrical constraint on the bottom line of the rectangle, relative to the y-axis. First, select the endpoints of a line, then select the drawing center point, and click the Symmetric Constraint tool. Select the strip length line, then choose the Dimension tool and press Enter. Click the small expression icon in the length cell, and then select the Dimension spreadsheet, and the cabinet width alias. Keep in mind that the two side panels will decrease the cabinet's internal width by the thickness of both boards. The strip length will be calculated by subtracting twice the board thickness from the cabinet width. Be sure to include a space between each component of the formula. Enter by clicking on OK. OK again. Select the strip width line, then choose the Dimension tool and press Enter. Click the small expression icon in the length cell, and then select the Dimension spreadsheet. Enter the strip width alias. Press OK. The sketch is now fully constrained. Close the sketch workspace. With the sketch selected, click on the pad icon to extrude the sketch and add volume. Next, click the small expression icon in the length entry field. Choose the Dimension spreadsheet and enter the board thickness alias. Press OK. We completed the strip body. Now create the next body, the door. Create a new body. Rename the body to Door. In the door body, create a new sketch and select the YZ plane to position the door on a side plane. Draw a rectangle from the YZ center point and enter. Select the door height line, then choose the Dimension tool and press Enter. Click the small expression icon in the length cell, and then enter the Dimension spreadsheet. And cabinet height alias. Remember, the door should not cover the toe kick area, and we need to include a small edge allowance around the door. The door height will be calculated by subtracting the toe kick height and twice the edge allowance from the cabinet height. Be sure to include a space between each component of the formula. Enter by clicking on OK. Select the door width line, then choose the Dimension tool and press Enter. Click the small expression icon in the length cell, and then select the Dimension spreadsheet. Enter the cabinet width alias and deduct the door edges. Press OK. The sketch is now fully constrained. Close the sketch workspace. With the sketch selected, click on the pad icon to extrude the sketch and add volume. Next, click the small expression icon in the length entry field. Choose the Dimension spreadsheet and enter the board thickness alias. Press OK. To differentiate the door from the other panels, we will fillet the front edges of the door. First, hide the other panels by selecting their bodies and press the spacebar. Select the 4 front edges of the door by holding the Control key while selecting them. Click on the Fillet icon and Fillet Parameter task menu will open. In the task menu's radius cell, enter a desired radius, for example 11 mm. Click OK. We can even change the appearance of the door. In the View menu, select Appearance. In the Display Properties task menu, click on the 3 dots in the Custom Appearance entry cell. A Material Properties submenu will open. Click on the diffuse color and select a color to your liking. OK and close. We changed the door's color. Hide the door with the spacebar. Now for the backboard. Create a new body and rename it to Backboard. Create a sketch and select a desired plane. I selected the XZ plane. Draw a rectangle from the X-axis. Apply a symmetrical constraint using the vertical axis. For the width dimension, enter the cabinet width in the expression cell. Similarly, enter the cabinet height expression. The sketch is fully constrained. Close the sketch. Pad and set the thickness to backboard thickness as defined in the dimension spreadsheet. Click OK. The backboard is complete. Hide the backboard with the spacebar. The front edges of the panels will need edge finishing, often called edging. To indicate this, we'll change the color of the edges that require finishing. First, however, we need an additional strip with an edge finish. We'll duplicate the existing strip body and rename the copy accordingly. Select the strip body, go to the Edit menu, and choose Duplicate Selected Body. Uncheck the Dimensions spreadsheet, as a duplicate is not needed. Click OK and rename it to Strip with Edge. Select the shelf, press the spacebar to display it, and set it as the first body to highlight the edge for finishing. Zoom in to easily select the edge that needs recoloring. Click on any face of the shelf body, then go to the View menu and choose Color per Face. A task panel will open, allowing you to set appearance per face. Click on the edge of the shelf that needs recoloring. The face number will appear in square brackets, indicating the selected faces. Next, click on the three dots next to Custom Appearance. A new panel will open for setting material properties. Select Diffuse Color. In the Color panel, pick the color for the finished edge. If you choose a custom color, you can save it to custom colors for easy reuse on other edges. Click OK to close the Properties panel, then OK again in the Task panel. The selected edge is now recolored to indicate the finished surface. With the shelf body selected, press the spacebar to hide it. Select the side panel body, press the spacebar to display it. Zoom in to easily select the edge that needs recoloring. Click on any face of the shelf body, then go to the View menu and choose Color per Face. With the Appearance Task panel open, click on the edges of the shelf that needs recoloring. The face numbers will appear in square brackets, indicating the selected faces. Click on the three dots next to Custom Appearance. In the Color panel, pick the custom defined color for the finished edge. Click OK to close the Properties panel, then OK again in the Task panel. The selected edges are now recolored to indicate the finished surfaces. Repeat the same process for Strip with an Edge. The list of cabinet body parts is now complete. We have the side panels, shelves, construction strips, door, and a strip with a finished edge. However, we still need a back panel for the toe kick area. Since the back panel shares the same dimensions as the construction strips, we'll use one of the construction strips as the toe kick back panel. We're now set to assemble the base cabinet with the body parts we've designed. Begin by going to the assembly workbench and creating a new assembly. The new assembly will appear in the model tree. The first body imported into the assembly will typically serve as the grounded or anchored component. We'll select a shelf as the grounded item. Click on Insert a Component and select the shelf. When prompted to ground the first inserted part, click Yes. This shelf is now grounded and will serve as the bottom shelf. With the Insert Component panel still open, double-click on Side Panel to insert the two side panels. Select the second side panel and drag it to the side. Move the first panel closer to its position on the bottom shelf, then zoom in for a better view. Close the Insert Component panel. We're now ready to attach the side panels to the grounded bottom shelf. To fix the side panel to the shelf at a specific point or vertex, click on Create a Fixed Joint. A Create a Joint panel will open. Select matching vertices on the shelf and the side panel to connect them. Ensure that the planes of the selected vertices point in the same direction. Slight mouse movement can adjust the vertex direction. When you select the second vertex, the panels will align. If the vertices are connected but the orientation is incorrect, enter a rotation value until alignment is achieved. In this case, the panels are correctly aligned, so no rotation adjustment is needed. As we do not intend to rotate any panels, we'll confirm the fixed point. Close the panel. The first panel is now in place. To attach the second panel, repeat the fixed joint process. Click on the Fixed Joint tool and select the two vertices to join. Once the second vertex is selected, the panels will snap into position. Close the Create a Joint panel. The two side panels are now positioned with the bottom shelf. Next, we'll select and insert the face end strip as the next component to attach to the cabinet. Click on Insert a Component, then select the strip with edging. The strip will appear in the assembly workspace. Move it to the desired position. Zoom in and close the Insert Component panel. Now we're ready to attach the front strip to the cabinet. To fix the front strip to the cabinet, click on Create a Fixed Joint. While the Create a Joint panel is open, select matching vertices on the strip and the side panel to connect them. When you select the second vertex, the panels will align. Close the panel. Repeat the process with a strip. Rotate to view from behind. Close the joint panel and insert the next strip. Rotate and position the strip so that it's conveniently aligned for attachment to the cabinet. Fix the matching vertices. Here, rotate the joint by 180 degrees around the fixed vertices to properly align the strip with the cabinet. Once aligned, close the joint panel. Next, we'll insert the second shelf. Since it shares the same plane and orientation as the grounded shelf, simply move it upward to the desired position. To insert the backboard, rotate the cabinet to the back. Insert the backboard. Position the backboard so that it's conveniently aligned for attachment to the cabinet. Zoom in and fix the matching vertices. Rotate the backboard as needed to align it with the cabinet. In this case, rotate it by -90 degrees around the fixed vertices to ensure proper alignment with the cabinet. Once aligned, close the joint panel. Rotate the cabinet assembly to a front view to prepare for door insertion. Insert the door component and move it to simulate an open position. We'll skip including the concealed door hinges in this design, as that is a standard installation. Here, we're only demonstrating a semi-open door position. Now, for the toe kick back panel, we intentionally chose construction strips that match the toe kick height. This approach helps to minimize the cut sheet quantities. Insert a strip for the toe kick backboard and attach it to the cabinet using the same method as with the other panels. Our cabinet design is now complete and ready for the next step. In future videos, we'll expand our design series to include other types of cabinets and delve into the technical drawings for these designs. Don't forget to like, subscribe, and leave comments on future DIY designs you'd like to see. Thank you.